So first of all, I put in the, close the browser. I put in the website the scripts or most of the script that we saw last time for visualization. So now if you go to 3.7 visualization 1, so there is a link here that says scripts. So most of the scripts that we saw last class and some of the ones that we are going to see today are there. That may take us like 15-20 minutes, and then I would like to show you something that is pretty interesting, I think, which is interactive plots with Python using a package called Plotly. And again, you can find the scripts right here. So if you want and try to download, and we can just execute them and see if it works. Sometimes Plotly is a bit how to say, complicated in order to make it work. Initially it will work, but sometimes there are some things that you need to do around it to make it actually work. So any questions from last Friday? You guys had the chance to look at the slides, or you probably want to use it later when you have to do your presentation module or something. But something that may be useful in that regards is how to generate animations or movies with Python. And actually, when we say animations or movies, it's just like a sequence of frames, right? And that is how basically movies and videos usually are played. It's a sequence of frames that they change slowly, something, but very quickly in the pace that they take, so it looks like a continuous motion or a continuous displacement or something like that. The thing is that Python itself, and this may be a technicality more than anything, cannot create animations, but just images. But that's all what we need actually to generate a movie, because of this way that movies are basically displayed. What we also are going to need is what is called an encoder. And an encoder is a program that basically takes this sequence of images and put together in a kind of a standard format, like MP4, AVI, MPEG, whatever is your favorite movie format. The ones that are, or the two that are more or better for this are FMPEG and MenCoder. And actually, FMPEG is quite straightforward to install in most of the platforms, in most of the operating systems. You just go to the website. I have it right here. Just select your operating system and basically we install it. The only thing that sometimes, depending on the operating system, you have to take care of is set the path that the operating system, so that the operating system can find it. What else? So if you remember that last time we talked about DPI for taking control of the resolution of the figures. There is something similar for the movies called bitrate, and that basically gives you a flavor of the quality of the figure. So that's something that you guys can take a look into if you want to play with that. Yeah, the encoder I already mentioned, but basically FMPEG will allow you to generate MP4 and MPEG. I'm not sure about Avis movies, but probably two. If not, there are tools to convert one into each other. Okay, so let's take a look at quick script. Oh, sorry. Oh, I started in my last. Okay, so anyway, let's take a look at a script that generates a movie, and we're going to see that after. And this is taken from the Matplotlib website. So Matplotlib also brings some animation modules, and the idea is that it will generate this sequence of images. So we are going to use NumPy as before, we're going to use PyLab, and we are going to use the animation module from Matplotlib. So the first thing that we need to know, or to tell the script, is which encoder, which of these programs that put all the images together we want to use. And in this case, I have installed FMPEG. So basically, I'm saying, okay, whatever is my writer is going to be from the animation writer's FMPEG. Then I'm filling something here, which is, in most of the cases, is quite useful. It's called metadata. And usually is information about the data, in this case, information about the movie. Think about a playlist when you are listening to music or something. When you see the artist, the year, the album where the song was recorded, all that is metadata. It's information about the data if you wish. And in this case, I just made up something like title, my first animation, artist, myself. You can fill many others. And it's just a dictionary. If you remember the Python types, it's just a dictionary. Then we're going to specify some features of the movie. So we define writer associated with the object ffWriter that we defined before. We set the frame per second. So this is how fast each of these images is going to be displayed. A typical or standard way is 15 frames per second. That is good enough so that the AI doesn't realize that actually there are sequence of images that are being displayed one after each other. And it gives a smooth and nice transition between each other. And then I'm setting the metadata of this movie. I'm going to generate to this metadata. I should have chosen a different name, but basically this is the label or the function within the writer, and then this is the dictionary I just created here. Okay. So this is just more kind of bookkeeping kind of things. Now we are going to open a figure. Okay, and this one we saw last time. I'm using P for referring to PyLab. And this is a trick if you wish to open an empty plot. So you create an empty plot with brackets, so there is nothing to be plotted. And then you set whatever is going to be plotted there to use black and dots. Okay, so that sets the default for that figure, for that canvas. So whatever is plotted there, I don't have to worry anymore, and I can do that. After that, I set the limits because I want to be the plot fixed, so I don't see in the movie changes in the ranges. I set the limits in X and Y to be from -3 up to 3. Okay, and then I set 2 arrays that's going to be filled with zeros. So X0 and Y0 are 10 elements filled with zeros. Okay, what we are going to do actually is to have 10 dots randomly moving in the plane. Okay, between -3 and 3. That's the whole idea. Then this part is where actually happens all the action, either the animation or, and in this case, it may sound like a silly example because it's just random dots, but you can think about this like temporal data that you have, and you want to represent this data changing in real time. So this first part is where basically we tell Python that we want to generate what kind of movie, how many frames, after all, 200, what we are going to use as the images that we are going to produce, this fig handle that we created at the top. And then the coding is basically with writer saving, and you put all these things good. This loop, this for loop, is basically for randomly move these points. So you will be seeing the points moving randomly. So basically what we take is each of these 10 slots in the arrays represents the position X and Y of these 10 points. And what we do is we just add some random numbers to each of these elements, and we create just a shift 0.1 so that they basically move around the origin. This L operator is the one that we just defined in the star line over there. So basically what we said is update the points, the positions, with the data coming from X0 and Y0. Okay? And because it's set with those parameters, we don't need to specify anymore. The last point is just grab whatever image was generated and bundle together with all the other images, and that will produce the movie at the end. Okay, is that more or less clear? Yeah, okay. So this is how it looks like the movie at the end. So this is the actual MP4 figure. You can see the limits are fixed between -3 and 3 in both coordinates, X and Y. And then you have the points start randomly at the center, and they start to spread because of the random additions to their positions. If we haven't set the limits, probably what Matplotlib will try to do every time that we ask it to plot is try to adjust the limits to which are the positions of the points. So that will give the idea of this frame kind of shrinking and expanding randomly as the points move. Okay, and as you can see, this repeats for 200 frames, and start again. So it's not hard, it's quite straightforward. You can think of more complicated things to do, especially with your own data sets. Again, this can be interesting, like if you have a time varying property, you can either put dots in your plots or if you had a field, represent that field and how it changed with time. I think I have another example a bit more interesting. This is kind of random or Brownian motion, and you see this, I don't remember, maybe 200 points or something like that. You remember, Francis? Or it's one of your simulations, right? Molecular dynamic simulation, and again, some randomness there, but the principles and the ideas are exactly the same. Okay, and you have way more examples here. So I think Matplotlib brings a nice set of examples that you can play with. Okay. There's one more thing I want to show you. This is the slide actually with which I started. But there is something else I want to show you, and actually two more things before jumping into the interactive plots. One is that, and I mentioned this because sometimes this is useful for depending on your field of research. You have the possibility of manipulating images with Python. And basically there is this package image, capital I, that allow you to do that. We're going to use again PyLab for many things like visualizing and so on. I have an image there. It's a particular image, and I will tell you why we choose this image. It's a cartoon representation, I would say, from the Mount Fuji. And the first thing I'm doing is just reading the image, and that is very simple with the image package. Is im.open and the name of the file. Okay, so I'm reading that, and then I'm going to fill in two arrays, nx and ny, the dimensions. And basically, because the image is nothing else than a matrix, it's a pixel representation, right? X and Y coordinates with different values. In particular, if you are using the RGB representation for colors, goes between 0 and 256, depending on how many colors you want to represent. But basically, I want to get an idea how big this image is. So I say that the shape function from Python gives me basically those dimensions. 0 for X and 1 for Y. Okay. Going to use another auxiliary variable C there to keep the data that I load. So basically from the image I want to keep that. And then I'm going to create an array. It's basically a matrix, a two-dimensional array, full of zeros with coordinates or sizes nx times ny. So basically a Y canvas, but the same dimensions if you wish as the image. Now what I'm going to do after is I'm going to take each of these directions, x and y, and I'm going to go pixel by pixel. So this is this nested for loop here. Okay, and in the B array that was filled with zeros, I'm going to load the third component of the C function that we just used. So the C basically will contain the three components of the image. So the RGB components of the image. So this is the image. This is nx, ny. So we will have pixels basically, and each of these pixels has three components: 0, 1, 2. And this is going to be the representation of the color red. Oops. Red, green, and blue. Okay. And one thing that you may notice, and this is where you need to know something about the image, of the type of the image, is that this image is kind of bluish, right? The predominant color there is kind of bluish. So I want to particularly pay attention to the blue, which is the third component of the array in each pixel. Okay. So now what I'm going to do is from that, so I basically load what is called the blue band of the image, all the blue components of the pixels in that image. So I'm going to compute the gradient of that array. So now I will have a matrix basically with values that goes between 0 and 255 that represents the blue component of the image. And what I want to compute is the gradient, if you wish, the two-dimensional derivative of that image. So how the blue color changes across the image. That's what I'm looking after. You can think about this like as an edge detection technique for the color blue. And because the image has predominant blue color on it, is basically we're going to try to detect which are the edges of the image. So this is all information if you want to see how this looks like and and how the gradient looks like, you can print it. Okay, and the other thing is because I want this, so the gradient, you know, when you have a mathematical function, can goes up or can goes down. It tells you about how is it increasing or decreasing the function. But the minimum or maximums are given always by 0, right? So I can take the square of these components and just look at that. So now I'm going to repeat the loop I did before, but now I'm going to change the gradient, the components of the matrix, by the square of the gradient that I just compute here. And I'm going to ask to fill the values of the image now, choosing between the minimum value or 255. I mean, I will try to saturate basically the image with those values. I'm going to basically set the values again for the image. And then, because C is the handler of the image, of the matrix of the image, I'm going to show the image again. And we're going to see how it looks like. And after you do that, this is how it looks like. So this is basically a technique for detecting edges in the image. And because it's predominant blue, we can just look at the blue band of the image. Okay? If you look at your phones, probably there is an app when you take the pictures that allow you to do that in a shot. But basically, the algorithm behind is this, right? This can be useful, especially if you are tracking things moving in a movie, right? Because remember, movies are a sequence of images. So you can design an algorithm that first detects the edges, detect an object which is moving in the image, and then because of the sequence, you can track that object.
It's sort of like the same software that's used.
I guess, well, I would say the technique probably is more sophisticated because there are much more things involved, but the ideas is kind of the same. At the end of the day, images are just a matrix with much or less resolution, with much or less colors and values for each of the elements, but the ideas are the basic ideas are those. Yes, that's right. Okay. Any questions? Again, this code is in that set of scripts, so you can take a look at it if you want. Okay. And you can change the colors, you can change the image, and then instead of looking at the blue band, just change here if it is predominant green or red or something in the middle. Okay. Yeah, the last thing I want to mention, and this is because it's kind of just for complementing information, I would say, is that Python is used in many different frameworks related to visualization. I don't know if you have heard of it, but ParaView and Visits are two open source packages that are used for professional scientific visualization. Basically, let you load the data, depends on the formats and so on, but let you load the data, and it has a nice GUI, and it runs in clusters and run in parallel. It can do like real professional stuff. The nice thing is that you can actually program in Python within those. And there are a lot of tools and libraries that those provide. So you can do some sort of, as you may have seen, maybe in, I don't know, the ones I'm familiar with are cosmological simulations where there is the Big Bang expansion and there is camera rotation around the stars and the galaxy forming. Those kind of things are basically achieved with these kind of packages, but also with Python scripts running on top of that. Okay, so just like a teaser slide, if you wish. Because we are talking about visualization, we mostly saw features from Matplotlib. The nice thing of Matplotlib, in addition to all these features, is that they have a very good documentation. So they have a gallery, and these are hyperlinks. So if you go into the slides and click on that, it takes you there. The gallery looks more or less like that, a collection of pictures and images. The beautiful thing of this is that you click in any of those, and it basically provides you the script. So you can adapt, if you see a plot or an image that looks like something that you may want to try because of your data or because it looks nice to you, just go there, select the one that you like, click on top of that, and you will have the script. And basically, many of the examples that we saw here are taken from there. So it's pretty straightforward to follow, I would say. In addition to that, there are tons of other packages. They try to achieve similar things as Matplotlib. They are built on top of Matplotlib, or they try to complement Matplotlib. The one that we are going to see immediately after is this one, Plotly, that uses a complementary approach in the sense that it tries to take your plots, which we can say are static in the sense that we cannot, other than move a little in the window, don't do much. It will try to make them pop up in live, and we're going to see what I mean with that. Then there is, between the ones that are most popular are Boken and Seaborn. ggplot, I think, comes from, if you have worked with R, it has a R flavor because it's also in R. These ones are more project-oriented, I will say, like BSpy and Mayavi or YT project. These are more apply, if you wish. And then if you are interested in developing kind of GUIs, there is this tool called tkinter that allow you to develop menus and interact with things. It's a bit more clunky, I would say, but still, if you want to develop an application in Python, want to create menus, your own GUIs, that is probably one of the ones to take a look at. Okay. I think I mentioned this from last Friday, but I have some complementary material, especially depending on the interface that you are using for dealing with Python. At the beginning, we discussed how the Jupyter Notebook will deal with things. But if you are using native Python in the terminal, for instance, basically this try to mimic that original slide that we had at the beginning, especially when you want to keep control of the terminal while plotting things. You will need to set the interactive mode on, and that's allow you to control the terminal at the same time as the graphic window. IPython, similar to Jupyter Notebook. And then there are a bunch of more of examples. I think we covered some of these examples last class, but there are more features and more examples how to produce kind of three-dimensional plots there. Again, these are also in the scripts. And if you are interested in looking into gravitational waves, there is a nice example of a simulation that produced not a movie, but a three-dimensional representation of gravitational waves. Okay. Any questions about this? It's pretty similar to the parametric curve that we discussed last time, but now there are two of these guys. Okay. So if you guys don't have questions, I will probably move to the second part, which is the interactive representations of the plots. For that, we're going to use this Plotly library. So this library, I think, is pretty neat because it allows you to create very nice looking plots, first of all. Secondly, they are interactive. You will see that it will pop up the plot. You will be able to zoom in, zoom out, drag the plot. If it is a three-dimensional plot, rotate it. But also, it will give you information about the data itself. When you move your mouse on top of the data, it will pop up with information. It will allow you to turn on or turn off points, those kind of things. The way it works is also pretty elegant or simple, I would say. It basically generates an HTML document. An HTML document is basically the web pages that we see. When we open a web link in the browser, that is an HTML document. The way that generates all the interaction is using some JavaScript underneath the HTML document. So it uses a plotly.javascript library, and it's built on top of a D3, what is called a D3 and StackGL libraries. These are open source, so they are accessible, they are free. Plotly is free. There are two modes that it will work. I will talk a bit more about this later. They have tons of different charts and types and three-dimensional plots that you can create. You can generate static images as well, like PDF or PNG or SVG. And it's open source. Okay. The other nice thing of Plotly is that in one way you can think of an API. It's like an application protocol interface and interacts not only with Python, but also with R, MATLAB, Excel, JavaScript, web app, Scala, a lot of other applications. The ones I have tried is Python and R. The syntax is different, of course, but the functionalities are pretty much the same. Okay. How to use and how to install it. If you are just using your terminal, or you have access to a terminal, and you have pip installed, just do pip install .ly, and initially it should bring all what it needs, all the dependencies that it has, it should install. To test that the installation was successful, just open a Python interface terminal and type import .ly. It may take a second or two because it's kind of big package, but basically, if it doesn't show you any error messages, it's very likely that everything went well. As I mentioned, this is an open source, free, and self-hosted service or library, but it has two different modes of operation. And let me try to explain what I mean. So there is an online mode and an offline mode. The online mode, what does is, whatever you produce, it tries to push it through a cloud service, which again is free. The only thing that requires is that you register with Plotly. Okay, you just give your email, you register like in any other website, and it basically creates an account for you. It gives you some credentials, and you need to activate your credentials through Python. So that's one mode. Depending what you want to do, depending what you do, it may be useful for you because you may want to share this with other people. You may not have a web page and you want still to post your plots there to share with collaborators or researchers. So that can be an option. It's a kind of, think of a Dropbox kind of thing, or cloud, if you wish. The alternative is to do things offline. So when you do things offline, everything happens in your computer. You generate your plot, you push the plot to your browser, it generates an HTML document, and you are able to see in your computer. Okay? So all my examples that I have for you today, I have taken most of them from the website, but I have adapted to be in the offline mode, so that you don't need to authenticate, set any credentials or APR, or create any account. Okay? Again, there are tons of information in the website. One of the nice things, but also that complicates a little things with Plotly, is that it's under very active development. So they have releases very, very frequently, which is good because they fix a lot of things, they create and improve and add a lot of features, but also what happens is most of these features are not back compatible, or they break things. So you need to be a bit aware of that and of the version that you are using. Okay? I think my examples are still working in most of the releases. It's like a year old or so. So I don't think there's something like really serious, but just be aware of that sometimes they change things for improving or for robustness or for adding more features. So that sometimes creates some problems. That's the other thing. You have the ability also of, instead of generating the plot and just dumping to the browser, you can save your plot using this HTML widget framework. And it will basically, what it will do is basically save your plot in an HTML document, but it will add a subdirectory containing all the libraries that it needs to be run anywhere. So basically, as I say, if you have a website, you can upload that, and your plot should work with all this information. Okay, so let's say that you're happy with the offline mode. If you are interested in the online mode, I think I have a link in the previous. Yeah, so if you're interested in looking into the online mode, just go here. It's 2 lines of instructions for setting. After you create your account, you need to set your credentials. It's just 2 lines where you copy and paste some kind of key code that they will return to you, and you're ready to go. It will basically, if you have an internet connection, it will basically go transparent through it. When you want to use the offline mode, and this we're going to see more concretely in the examples, you can use Plotly, basically the library, offline, and then plot or iPlot, depending what kind of plot you want to generate. But basically, that will create whatever happens as an HTML document that is going to be saved in a temporary file in your computer. You will see specifically where, because it will show up in your browser in the top. But basically, that's the way that you can access. Sometimes it needs a bit more of tweaking, but basically that's the way. As I said, there are a lot of examples, especially for Python and R. So in any of those links, you can go and see examples about Python and R. So I choose some of those, the very basic ones, just to get used to the nomenclature if you wish, and then some ones that I think are interesting. And as I say, most of my samples of all of them has been taken from the website and modified or slightly modified so that they work in the offline mode. So this is my first example. It's a simple one, but that will allow us just to go into it and see which are the elements that we need to take into account. And one thing that you will notice is that Plotly emphasizes a lot this kind of object-oriented nature that Python has. So we start by just importing Plotly, and then from Plotly we are going to import the graphical objects. Basically, graphical objects are all kind of charts and plots that we can create. I'm going to rename as Geo, and then I'm going to create an object called trace1, which is going to be from the graphical objects a scatter plot. Basically, I'm going to provide the coordinates right there on the fly. I could have my data already loaded, but I'm going just to create 4 points, 1, 0, 2, 2, 3, 3, and 4, 5. I'm going to say that I want to be this a plot where it's filled from 0 to I. And then mode, no, don't worry about that now. The trace2, which is the second set of points I want to plot, again, is a scatter set, coordinates, x and y, whatever you want, but the fill is until the next I, to the next value of y. So what this does, and you will see, trace1 is the orange one, trace0 is the blue one. I create kind of a dictionary or data frame, if you prefer, with data composed by trace1 and trace2, and then just set that or give that to Plotly and push it. What this will show is this plot, and if you see trace1 in this case, which is the one that goes to 0y, basically fill from 0 up to the value of the point. And then the next one, trace2, goes from wherever was the value of trace1 until the value of the point defined by trace2. So it's kind of relative. So far, it's a nice looking plot. It doesn't say much. Let me see if I can run this for you. So I have here all my examples. And so this will open a bunch of plots because I have all of this together. Let's see if we can find the right one. So as you can see, what it's doing is basically executing the Python scripts and creating each of these plots one by one. So now I had to find the right one for you. Find it. So all these plots are generated just by running that. I think I have the one. Okay, let me go to this, the previous one, which I think is the next example I have in the slides. So that's the next example. It's very similar to the previous one. Now the difference is that you will notice that I don't have in the trace0 2, 0, right? So instead it will fill the values between the two curves or the two data sets. So let me show you how that looks in the browser actually. So there we go. So this is the image that was generated in the browser. So far, as I say, it's a nice looking image, but when the interactive things come out is when you go into the image and you go through the points and all the data that you feel is right there for you. Furthermore, you can zoom in. It will zoom in the region. You can double click, go back. You can turn off or turn on the traces. So now I just turn off trace1. I can turn it on again or turn off trace0 and again. Okay. So that's the kind of interactive thing that we are talking about. All right. In the script, you probably will see a bit more of detail. So this is the color. You can define the colors in the same way that we were talking before. Give it the RGB code for the color or choose a predefined color if you wish. You can set different colors for the lines or for the filling. Yep.
Let's say you picked slide. So fill would be instead of 2.
That's right. That's right.
So
yeah.
So you still get separate.
Yeah. So this. If you remember from the previous example, in the mode I said none. So there are no lines. I don't know if you can notice, but there are no lines connecting the dots. In this example, it's a little detail. You probably don't see in the projector in the slides. You can see better. The color of the line is a bit stronger. So what is that? So when you set the mouse to line, it changes a little bit the color of the filling to complete that. See which other example I have here. So this is just a scatter plot. We are just sampling 1,000 points randomly from the random distribution, passing the data again. This is an example where the data already exists. We don't need to define on the fly. And you set the random X and random Y to be the values that you want to plot. And then in this case, mode is markers, which represents points. So the data in this case is just this trace as the object that you usually create. And again, you basically set the data. The nice thing is when you create the offline plots is that you can give a file name and it's going to save that file name for you on the fly. So there will be a basic scatter.html file that contains all the information for you. So let me see if I can show you that one. So you can see there are so this is the one that I was talking about. Again, when you pop your mouse on top of any of those points, it gives you the coordinates. You can zoom in, and again, you get the coordinates. If you go, let me see if I can see you. Yeah. So if you do view page source, which basically will show you the source of the HTML file, it's taking some time because it's loading basically the data of 1,000 points. So embedded in all this mess is all the coordinates of the points, plus a lot of coding for making the plot looks as it likes. Okay. At the very beginning, these are, here. So at the very beginning you see, and find it here, somewhere embedded in this mess is the calls to in other examples it's going to be easier to find, I think. Okay, so here are the calls to the Plotly JavaScript libraries. So all is embedded in that document, including the information. So that's something that you want to be aware as well. If you want to show this plot, the data that you are presenting is part of the HTML document. Okay, so just to make you aware of that. Let me see what else. So this is another example. It combines scatter plots, lines with dots, and line without dots. And you can see there are 3 traces, one for each of these. Markers alone, line plus markers, and just lines. I think I had that example also somewhere over there, right here. And again, it gives you on the one side the value of the points, but also the labels, how you have labeled the data. So you see markers was labeled as markers, lines plus markers, and lines. So it's kind of very elegant for displaying data and showing data and inspecting data even. Like I can go and see values right there. And it's not so complicated to code. We were teaching another course right now with R, and again, as I say, Plotly also works with R if you have data with R. And someone mentioned, there is a Google tool that does something similar, but it's way, at least what I saw was way more complicated to implement those charts using the Google tools implemented with R. So this is, after you realize more or less which is the spirit of how to code things, is pretty standard. It's like you create the object, you select what kind of what mode, the names are here, the labels that are shown there, and then it's pretty straightforward, I would say. Let's see what else we have. So these are again more scatter plots with different encoding or colors. It allows you to do transparencies as well. You can remove or put access. All the features that you may expect, they are there. See if I had that example there. So this is the other example. So you have two sets of points, and again, all the information, the zoom in, zoom out features are right there. So these are kind of the very basic examples that they give you like the idea of what is each of these parameters doing. You can set, again, this is another scatter plot, but now you can set your points to also represent information associated with magnitudes. In this case, it's again 500 random points. Again, the mode is markers. I can change the size to make them look a bit bigger. So that's something that probably you want to look at. And then I'm setting the color, and in this case, I'm just randomly given colors. But you can use another feature if you have 3-dimensional or 4-dimensional data. You can use another feature and then represent this with a color bar. And you had, again, like a lot of different color maps. Like I think we talked about a little about this last class when we saw the contour colors or contour curves. And then you can basically just there show the scale, and it will basically show the scale right there. So let me see. So this is another example. I don't think I put that in the slides, but this is the one I was talking about. So you can see the colors, and you can see right there which is the scale and which is the value associated with that. What else? More type of charts. In this case, bubbles is again markers. And another different way that you can represent information is by setting the size associated with the value of the information. So in this case, I have 4 points, and in this case, I'm using the size as another indicator. I can use the size also with colors, and this opacity thing also controls how transparent you may want to do or to create the object. So that is a nice feature as well. It's a more peculiar plot. See if I can find that one. Oh, this is the basic one with sizes but not colors. But now you can give the colors, and you can also change. You can see the pink one is way more transparent than the tiny blue here. And again, you can control all the things and look at and inspect the data just by browsing on top of the points. Or bubble plots. So this one has 4 sets. You can embed also HTML code within. So when I set text, you will notice these brackets or triangles. -br is HTML code. So that means a new line or an enter. And again, it's the same kind of plot, but with more detail. So now, if you look at the plot, you will have more information actually popping up. So this one is good to see there. So now I can give more information about each of these points, the size, the reference, the type. I define type B for the second one, type C, D, A, whatever. So there is more information that you can provide. So that's the flavor of the interactive plotting here. And the idea is to show you a bunch of examples. You may find more close related to ones than to others, and starting with the very basics. More bubble plots, kind of like bubble plots, I think, but it's kind of the same. Oh, this one is cool. So let me show you this one. So this is a kind of surface representation. It basically will read data from this website, so you can read with pandas. Ramses talked about pandas some time ago. You can read the data directly from that website, where it contains the elevation for a mountain in a CSV file. So the set data will have that. So we are going to define our data set, if you wish, again as a graphic object type surface in this case, because it's basically a surface. And basically the only thing is I'm going to take the data that we just read, and I need to have represented as a matrix. So similar ideas before, I have this matrix kind of grid representation where the layout is the x and y coordinates, and each of the values in those slots of the x, y components of the matrix are the elevation of the mountain. Now things get a bit more specific, if you wish. So I can define a layout, which is going to be the layout of the plot. And again, it's the layout of object of one of these graphic objects type. I can set the title of my plot. I can set if I want to auto size or not. I can set the width, height. I can set the margins. This is good for controlling and trying to remove as much possible white spaces, so your plot actually takes most of the canvas. And then the plotting is pretty straightforward. You just do graphic object figure. You choose your data set. You could or could not specify the layout. In this case, I'm specifying the layout. And then you push this through the offline plot utility of plotly. And in this case, again, I'm creating an HTML file that is going to be saved in the same directory as the script. And it generates that and the interactive plot. So let me see if I can show you that one. Oops. I think it's this one. Let's see. So it's reading the document from the website, and this is how it looks like. The nice thing now is I can go on top of the surface. I get the ISO surfaces automatically represented there, the values of all the coordinates. I can zoom in with the mouse, zoom out. But because now it's a 3D, I can click and drag and rotate the plot all the way in all the directions. Zoom in, zoom out. So that is pretty neat, I think. And again, you get all the ISO surfaces, the projections on the planes of the points where I'm having the values, all the data that basically is there is popping up in front of your eyes. Then I have another example with surfaces there. So this one, again, is defining values for a surface in a kind of matrix shape. So this is same as before. Now it's just directly a matrix, and recomputing two more values. So this is one surface, and then I'm displacing one surface up and one surface down. And then I'm going to directly plot the surfaces. Notice that I'm being kind of not too careful here because I'm doing everything on the plot. So I'm calling this case the plotly offline mode P off, and then calling plot from there. It's basically the same that we have been doing. I just shrink that. But I'm creating the dictionary, that type of object, a graphic type of object on the fly, and setting set 1, set 2, and set 3 to be surfaces. And what I'm changing alone is the opacity, the transparency level, or the alpha channel, if you wish. And what it represents is these three surfaces with different opacity. So this is the original one that I didn't specify any opacity. And this two has 90% or 10% of opacity, 90% of transparency, if you wish. And let me show you how that looks like. So again, every time that goes close to one of the surface, the mouse, it gives you information about the isosurfaces of that surface. You can again rotate in any direction, up, down. All the information pops up. It says which trace is the information coming from. You can zoom out. You can double click is not working, but you can go back to. It's not on here. Oh, yeah, it is. Oh, this blue thing is because I don't know why it's there. If you reload, it will basically those things. Now, notice in the browser, where we basically type the URL, that's the location of the file. Okay, and that's where I'm running things from. Downloads, plotly. And this file is called multiple surface dash or .html, and that is because I indicated. I indicated to use that file name there, and if I go to that directory, I just do a dir. Where is that? I do a dir. I have generated many of those. Multiple surface HTML. Okay, so it's pretty straightforward to generate these HTML files as well. Okay. Any questions so far? I just had a couple more of examples that I think you're going to enjoy because, again, I did some things. We are almost done. So this one draws streamlines. Same things. The only thing I'm also loading now is this figure factory. So these ones are new examples. So these ones are probably not available if you are using I don't remember which is the version, but probably 2 versions before the latest one of Plotly. These features, the ones that I'm showing from now on, are not available. In this case, we are just going to generate some arrays from -3 to 3, and then so this mesh grid we saw before is going to create this kind of grid representation, and then I'm going to define 2 vector fields, which are basically the tangents to a streamline. So a streamlines, you can think of a fluid in motion, and you put like dots of ink or drops of ink in the motion in the fluid, and if you see the traces, it's basically the stream. It represents the velocity of the fluid. And so I'm just giving some random expression for that, for the x and y components. And creating those streamlines is as simple as giving the coordinates of the mesh and then the velocity field, u and v, which you can think of the x and y components of the velocity of the fluid. You can set many things. One thing I set here is the scale of the arrows representing the fluid, which is like taking the tangent and drawing in which direction it's growing. I set to 0.1 is relative to the size of the streamlines. Again, I rename the offline mode as PO, and then plot. Figure is basically this handle of what we just created, the streamline. And I set the file name. And let me run that for you. It's called Streamlines. There we go. And you can see, so you get all the information again. You can zoom in the streamlines. You get the arrows, the directions in which the fluid is moving, or whatever field is represented there. Okay. So this is one of the nice features that Plotly has incorporated. And the other one is that it has the feature of working with maps. So I have 2 more examples, I think, or 3 maybe. But this showing how we can actually use maps in addition. So it gives you this idea of actually plotting data on a real map. So we're going to use Plotly again. We're going to use pandas because we're going to read data from US cities, like population from 2014. If you want to see what is in the data frame, just do df head. It will tell you. Now I'm creating here some labels. So it's basically the name, the population of the city, and then divide by 1,000,000 because the data is in million of inhabitants. I'm going to create some limits for the plot, and then colors. So each city will have, or depending on the population that you have, you will have different colors representing each of the cities. I'm going to initialize empty dictionary for cities. I'm going to set a particular value for the scale, and then I'm going to fill this dictionary with the positions, latitude, longitude. The type is going to be a scatter type, geographical, because it's going to be on the map. And then the size is going to be proportional to the population divided by this scale that I just created. The color is given by this, so I expect to have 1, 2, 3, 4, 5 colors, 5 different colors, depending on which range of population we have. And then the name is given by one of these fields of the data frame. So every time I find a new city, I basically add that to the dictionary, and this will create one entrance in the dictionary of cities. Okay, so this is more or less just processing data. How we plot this, and this is the plot that you will get. So you will get the map of the United States, because the cities are coming from the United States, and then the 5 different ranges in million from 0 to 2 million, 3 to 10, 11 to 20, 21 to 50, and above. So the title, basically, we want to show the legends just to know which colors represent what. Because it's a geographical object, we need to set the dictionary to set what is the scope of the map, in this case, the United States. The projection, the type of projection, if you want to show the showland, the landmarks, if you wish. In which color you can set that. The divisions for countries and subunits within that, and which colors to use. So this is the layout of the plot, and then the data come from the cities, and the layout is given by this definition. And then you just push that with plotly. So let me see. What I call that one? Bubble maps, I think. So this is the map. Okay, looks good. Before it wasn't like displaying the colors. And you see, every time that you pop up in any of these bubbles, it provides you the information associated with that. Same features as before apply. If I want to turn off one of those categories, I just click, and I can pop it up or pop it down. I can can displace the thing, and I can zoom in and zoom out. So it's a very nice tool for displaying also geographical information. Most of the code that you saw is basically manipulating the data and defining the scale, but it's not neither too complicated. This one I think is pretty cool. So this one will use the whole globe, and it will try to draw isocontour surfaces on the globe. Like think about weather predictions, isotemperature lines, barotropic lines, those kind of things. So we're going to use pandas again to read some data, a variety of tools from Plotly, so that's why we are also bringing plotly.plotly. So the first thing is that, and this tool, this code, it should work in Python 2 or 3, so depending on what version you are running, you will import one or the other tool for the IZIP codes. So we read data from this location about the contours of the globe. Again, we are going to define a bunch of scales here. Again, an empty dictionary. And then go looking for latitudes and longitudes in this data frame and setting the values there. The most are going to be lines, so you will see lines drawing the isosurfaces, but they are also contours, sorry. But you can set whatever you want, markers or even surfaces. It's going to have width of 2, and then the color is given by this scale that we just defined. Okay? So this is kind of the digestion of the data and processing of the data. And this is the layout. It's a bit more complicated in this case, but basically you are going to have the projection of the whole globe, and you can see the isosurfaces, the isocontour, how it will look like. So there are tons of options. You can show the land, show the lakes, show countries, show the oceans. I think you can set the color of each of the things. You can set the type of projection, the rotation, the original rotation, inclination, and angles for the original view. Of course, you will be able to rotate this and manipulate it later. If you want to show the grids, Cartesian coordinates, the properties of that, the latitudinal axis, longitudinal axis, and basically then the drill is always the same. You set the figure handle, in this case a dictionary composed by the data and the layout, and then you push that, you give a name, and that's it. So let me see if I can show you this last example. This is it. So this is how it looks like. Again, it pops up all the information of the contour levels. You can zoom in and zoom out, but now you can also rotate the thing and go seeing. You can see all the divisions, the political division of the countries in the map. All the information is still there. And as I say, this are the latest features, I think, from Plotly. So you have incorporated this set of tools that allow you to manipulate geographical information in many different ways. Let's see if I have something else. Oh, I have one more. Oh, okay. So this is if you want to do statistics. You can set also this kind of two-dimensional statistical distribution representations. So this goes basically does that. But there is not much new than what we saw before. It's just long because it has basically two distributions and then three representations like isocontours, but then projections of the distributions in the x and y coordinate. Actually, this is a nice example because it's the iris dataset. So it shows you how can different species of the iris flower be classified. And you can see that there are basically two clusters of information depending on the petal length and the sepal. But as I say, it's mostly what we saw before. Is again reading data from the iris dataset and then setting scales. The drill is always the same. Here you use a Gaussian distribution for classifying those values. Then you set the grid for creating the contours. Different traces. We will have 4 traces, 2 for the representations and 2 more for the contours. And basically setting the layout and pushing the thing through. So let me see if I can show you guys the last example. So it's a two-dimensional kind of histogram. And again, similar features as before, all the information for the contour levels, all the information for the distribution and the histograms are there. You can zoom in any part. It automatically resets the projections in the x and y axis. So it's showing the information correlated to what you are seeing in the center plot. Similarly, you can go and zoom in here and it will basically update the central part. This is a pretty nice example as well. At least you have, guys, a variety of examples. And again, if you go to the Plotly website, you will find like tons more of examples. It might be more suited to your needs or your research. But this is a pretty straightforward tool to use.